Hello all, this is Dr. Dave Maslach talking to you about reciprocity.com. The E is written with a 3, and in this particular video, I'm going to talk to you about what is a sample in research methods. So if you don't know me, I'm an associate professor of innovation strategy and entrepreneurship, and I created this whole reciprocity project to give back as much as I possibly can. There were so many people that helped me out that I wanted to pay the favor forward and help you out. All right. Before I go, I want to introduce you again. If you haven't seen her, this is our new puppy, Izzy. Come on up, Izzy. Oh, she doesn't want to come up. She doesn't want to come up. She's sitting down here. Come 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 here. Okay. Come here. Hello all, this is Dr. Dave Maslach talking to you about reciprocity.com. The E is written with a 3, and in this particular video, I want to talk to you about sample. What is a sample in research methods? So if you don't know me, I'm an associate professor of innovation strategy and entrepreneurship, and I created this whole reciprocity project to give back as much as I possibly can. There were so many people that helped me out that I wanted to pay their favor forward and help you out. All right, so I want to introduce you once again. I put out a video yesterday introducing Izzy. This is Izzy. She's a new addition to our family. She's a year old. She's kind of kooky, so she's running around. She wants to play all the time. So if you do hear, this is Izzy. But so enough about that. So what is a sample in research methods? So a sample in research methods is where you select some set of objects and items from a larger population that is more, and it's just, the reason why you do this is that the larger population is really difficult to measure and there's just too much going on. And so what you end up trying to do is we have this thought or this idea, if we can draw a representative sample, something that represents the population, the larger population, we could draw a smaller sample of that, then hopefully we can draw some inferences based on that sample about the larger population, right? So many populations are just really too large or difficult to acquire data on, right? So I'll give you an example. Maybe somebody's got, you want to study people with rare diseases around the world, right? And there's only, maybe there's only 2,000 people that actually have these rare diseases, but they're all located in all sorts of different parts around the world. It's going to be really hard to go and collect all of that data, right? So you might want to look for people within your country that have these rare diseases and draw some inferences based on those. So you get a collection of, maybe it's 30 people that are in your country that you can get a collection of, and hopefully that would be representative of the 2,000 people, rather than traveling and expending all these resources to go and get the whole population. So we could look at the whole population of the human race, right? And that might be billions and billions of people over the lifespan of history. But that's going to be really difficult to gather, right? So not only, there's 7.3 billion people in 2012 now on planet Earth, but then there's all the people that have passed away and you can't get access to those. So what you have to do is draw a sample from what we know right now. So maybe you grab 1,000 people and you grab those 1,000 people and you sample those 1,000 people, and hopefully you can infer something based on those 1,000 people to the 7.3 billion people that are here, but also the other people that have passed away before us, right? So there's lots of moments where we just can't collect all of that data, and it's just either physically impossible or it's just too taxing and it costs too much money to actually do this kind of stuff. So we end up grabbing a smaller sample that is supposed to be representative, right, of the larger population. So there is going to be problems that are going to happen when you do this, and we have to be very careful with this. And we're pretty aware of these in terms of what can happen with the sample. But what you can end up doing is that if you have too small of a sample, then it's very hard to sort of generalize to the larger population, because there could be If you have so to take an extreme, if you have a sample of 1 or even a sample of 0, right, which you could do, it's really difficult to make an inference based on that sample of 1 to the larger population. There's going to be lots of error, what's called error, that's associated with that sample, and it's not going to be representative of the population. Because, maybe you're looking at everybody in your city. Well, you draw the one person and you ask the one person about something you ask them some sort of thing and they have this really weird opinion. Well, it's not representative of the entire sample, right? Because they just have a weird opinion, or they're different, or they're unique. And what we're actually trying to do is, if you can imagine each individual person or each individual group having many different differences, and what we're trying to do is kind of look to see what is the sort of unifying thing that is associated with all those different things, right? So we're all very unique and all very different, but then we also have some similarities that are going on. And that's what we're trying to capture, these similarities across the sample that is maybe representative of a larger population. That's really what we're trying to do, right? And those differences above the similarities, right? So we all have these similarities, but then we're all different. Those differences are typically called error. Sometimes they're called individual, effects for the individuals, but then there's also error on top of it. There's all kinds of different errors, but let's just say right now is that those individuals have a small amount of error associated with them, and we're not measuring what we're intending to measure as much as we, what we want to do. The other thing is sometimes the sample is just not representative, right? So you take a large enough sample, right? So you take, so maybe you have 1,000 people and you just take, 300 people of those 1,000 people that you want to capture. Well, those 300 people could be, for whatever reason, you just grabbed a really weird sample, is not representative of the larger population, right? So then we have to draw more samples of the larger population to get more of a representative of what we're trying to actually look for, right? Sometimes this is the thing that I think trips up most people. Has nothing to do with sort of the statistics and the sampling and all that kind of stuff, but we just don't understand what the population is. So that's going to be the biggest thing that you have to sort of think about when you're doing research, is thinking about what is your population and defining what that population is before you actually go and do anything, before you understand what you're trying to actually study. Figuring out what you're trying to study is 80% of the problem. And actually studying that particular thing and doing that particular thing, that's 20% of what all the difficulty is. Once you figure out what the heck you're trying to study and what you're trying to look at, then it becomes easy to do all the rest of it, right? So that's understanding the population. What are you trying to generalize to, right? So for example, you might be thinking, well, I'm going to generalize to everybody that's ever lived. Well, that is a really big population to generalize to, and there's going to be all sorts of weird, unique things with everybody that ever lived, right? You imagine somebody that's from 100,000 years ago, they're probably going to behave a lot different than what they do today, to some extent. So what you want to do is pick the population that you want to generalize to. So maybe you want to generalize to, I'm going to pick Canadians because I'm Canadian. So you want to pick, generalize to Canadians that are in a specific location. Well, then that's your population, right? So maybe it's people that are from Northern Ontario, and you generalize to those people from Northern Ontario. Or you're thinking about a certain set of cities, and then you generalize to that certain set of cities rather than all cities that are out there. So maybe it's cities that are larger than 100,000 people have these characteristics, and that's what you sample. It's the same thing with firms or companies. That's what we study. That's what I tend to study, is maybe we want to look at smaller firms or larger firms, right? So firms that have more than 250 people are larger firms. That's maybe what we sample. Or the smaller firms, maybe we look at ones that are less than 10 people and we sample those particular ones and we try to generalize to those, because the companies that have 2 people are pretty different. I mean, we can sort of say that they're similar, but they're pretty different from the ones that have 100,000 people, right? And we can say, we might actually run into some problems if we start sampling and trying to represent that particular population, or we think that we're trying to, broadly represent all firms, but rather we should probably represent the smaller set of, the firms with with a small number of employees, for example. The other thing that ends up happening, and you could do this, is when you sample, because it's hard for us to understand what the population is, right? We often get that confused. That's the hardest part. But we often, because we're researching and we're trying to get at some of the stuff, we don't understand really what's going on. We often sort of neglect the complex patterns that are happening behind the scenes, and they're difficult to account for those things. There's all sorts of tools and techniques and stuff that we can do statistically to account for different patterns and complex patterns. But, so for example, if you draw your sample over time, right? So you take it 1 year, you draw it the next year, you draw the next year. There's probably going to be sort of time dependency. There's things that are going to change. There's some things that are not going to change. They're called time invariant over time. Maybe you draw from a collection of, maybe you draw from families, but families are part of a larger set of cities, and so there's going to be family effects and city effects that are there as well. And so you have to look at that and try to understand what all these complex patterns are and try to represent that as much as possible behind the scenes with your data and try to look at it statistically. That's what we try to do after the fact. Sometimes we try to collect data to represent some of those patterns, right? So we'll do cluster sampling of some sorts, but really what we're trying to do is trying to model what's really going on and account for what's going on as best as we can when we do these sampling techniques, right? And we have to use the noggin, right? Your head. Nobody's ever going to tell you that these things are going on. You have to use your head to figure out what's really going on behind the scenes and sort of make a hypothesis or a guess as best as you can in terms of figuring out what these patterns are before you actually go and sample some of these things. So sometimes you can get that information from previous research. Other people have done that, but often it is you're like, I've got to think about this at this moment, right? So that's why it's important to sort of think about things as much as you possibly can before you actually jump into sampling from that larger population. So in terms of, techniques and things and recommendations in terms of how do you actually sample a little better and making sure it's more representative of the population, this is just stuff I learned, right? This is kind of just, what I've done in terms of my own research is really the first thing, and I mentioned this, is just really have a good sense of the population. Really think about what you're trying to study. If you have a good sense about the population, then it's going to be a lot easier to sample. It's going to be, you're 80% done in trying to figure this out, right? So and sometimes you just don't even have to sample a lot of stuff if you narrow down the population in terms of what you're trying to study and explain with that representative sample. Now, the other thing is thinking about, how that sample could change over time or with different items or different people or different, objects, whatever it is that you're sampling, right? So, for example, in real science, in the physical sciences, we obviously, social scientists have this sort of complex, and they say that the real science is so much more, rigorous. So, being my background is engineering, and I realize that real science is just as hacky as social science sometimes. But anyways, so maybe in real science you're doing an experiment and you're looking at some chemical compound. Well, and then you take the sample because you're coming in, day out into the laboratory and you're doing experiments over the course of maybe 6 months. Well, there might be time effects that are going on behind the scenes, right? So the weather changes, for example, when you're sampling in with chemical compounds, that can affect things quite dramatically. Maybe it is one day you're just distracted and you don't do a good of a job of measuring. Maybe over time that the instruments are not becoming sort of reliable over time in terms of measuring different things. There's all sorts of time dependency stuff that happens. Maybe you're in a lab with a bunch of 5 other people and somebody starts goofing off or maybe they're doing another experiment close to you and some of the chemicals that they're working with leaches over and that just takes over time. leaches over to your experiment and then affects it over time. There's all sorts of different things that happen behind the scenes that you try to model and try to think about what's really going on behind the scenes in terms of gathering that data and thinking about what's going on behind the scenes. That's really what you're trying to do. Once you have a good sense of the population, then you want to gather the data. Just go out and try to sample. That's just gathering the data repeatedly over time and get a large enough sample. There's different rules. You have to go learn some of the statistics in terms of understanding what that is. But generally, once you get about 30, 30 of something, it gives you a pretty good, sort of sample. It's not perfect. And there's all sorts of different, statistical reasons behind it, but you need enough. You just need enough. And whatever that enough is, sometimes we need 1,000. Sometimes if we have 30, that's good enough in terms of a sample to collect, to understand the general population or the larger population. That's why you see in medical studies often you have a really small sample size. It's because the thing is pretty isolated, and the thing that they're focused on is very focused, and we can usually get statistically effects with a small enough sample, and especially if you're doing maybe it's a surgical procedure or you're injecting somebody with something. Well, heck, you don't want to inject 1,000 people with this thing because it could be harmful for them, right? So you want to reduce that sample as much as you can before you run into problems, right? So there's techniques and power techniques called power analysis. You can look up some of that stuff. And then the fourth thing, what you're trying to do is once you gather that data is you're trying to model those changes or those things that you thought about over time. Now, granted, that's going to require much larger data sets if you're looking for that. So always err on collecting more data than less data. Granted, there's cost to collecting that data, right? So in the example of a patient being harmed, well, reduce the data collection as much as you can, but try to collect as much that will allow you to model some of these effects, to rule out some of these other things that are going on behind the scenes. That's what you're trying to do. Statistically, that's what we try to do after the fact, is try to come up with all these fancy models to model what's really going on behind the scenes. And it's often, we just need more data. And the more data that we have, the better off we can model some of these things. Now, there's one more side effect that happens, not just sort of the cost of collecting data, but more data means more complexity, and it just becomes really hard to figure out what's going on behind the scenes when you just have millions of observations. I'm working with a data set right now that's got 12 million observations. Well, how the heck do you look at that, right? Like, that's really tough to look at 12 million observations over the course of 20 years. That's crazy. And so there's all sorts of different patterns that are going on behind the scenes. And so just have that in mind. Collecting more data is good in general, but that there's cost to collecting more data, and complexity and costs of time and effort, and as well as that there often can be side effects basically, or costs of harming somebody if you collect more data. So just to have that in mind in terms of what you're trying to do. So that is a sample in research methods. That's what we're kind of talking about, and what we're thinking about is we're just trying to look at how can we represent the larger population based on the smaller sample, because it's really hard to collect more data about the larger population. It's just really difficult. And we often run into different issues and problems that we try to think about in terms of how do we reduce the problems with that data in terms of making it more representative of the larger population. So if you like this video, give me a thumbs up. Do subscribe to the YouTube channel. Take care, and have a wonderful day. Bye.